All right, hello everybody. Thank you for coming to my session today. So I'm here to talk about how to achieve HoloLens, scale with the HoloLens with building information modeling, and specifically for our industry that we serve, large-scale, complex construction models. And hopefully this will be relevant to some of you if you're dealing with any types of models that have this level of complexity. So if your clients are building models like this, natural gas plants or airplane engine models, I'm just curious, anyone dealing with this type of geometry on a regular basis? Okay, good. So these are the kind of CAD models that manufacturers are building, engineers are building. These are not game engine models. These are heavy, high poly CAD models. For us specifically with Synchro software, we deal with what's called building information modeling, and these are full 3D models that represent the entire building system, down to the mechanical systems, the structural systems, all of that. So this is the challenge that we face, is how do we take this kind of content, highly detailed CAD models, and start to get that into the HoloLens. So this has been normal in manufacturing for a long time with aerospace and automotive, but now in the architecture industry, this is becoming quite common that these models are being generated. With us, Synchro, so we build software that takes the 3D models and then also allows our customers to generate a 4D construction sequence of that model. So not only do we have to deal with large, massively complex models, but how do you deal with the fact that you need to move through a timeline to see any moment in that construction simulation? So fundamentally, what we do, Synchro software, we take 3D objects, combine that with the element of time, it produces construction simulation. This is an example of one of our clients. This is Santiago Airport in Chile. Here you can see this is an output from our desktop application, importing models from Revit, from Navisworks, and then linking that to construction schedules to create a complete animated sequence for this job site. And this is under actual real construction, all being managed with detailed construction schedules. So it's not 3D Studio Max, it's not Hollywood BIM, this is true animated graphics being delivered at the job site and using construction sequencing. So this is the typical output that we have to deal with when our clients come to us and say, can we get that into the HoloLens? You know, they've already done the work. The nice thing is our clients are building the content for us just by importing the models and creating the simulation. The challenge becomes, how do you get that into the HoloLens? So we also have clients, hopefully you all have clients that are asking these questions. Can we get our models into the HoloLens? And do you have clients that are open to innovating and experimenting? Because to be honest, if you're going to play with the HoloLens, you have to have customers that are willing to go through trial and error. At this point, it's not like click a button and it just works. So it's good to have customers that'll be with you on that road and help you with that innovation. So hopefully all of these are interesting to you, and I want to just sort of take you through a quick walk through the path that we took to get to our current app that's in active development. So in fact, whoops, I want to hit play. This video is not playing. Okay. One of our clients, actually, there's two things I want to talk about. If you're dealing with a use case where you just have to load a construction sequence 1 or 2 days in the future, that kind of geometry can actually fit onto device. So we've been doing a lot of work with customers to do a limited scope of model geometry aligning with physical space. So taking digital model, the animation, 1 or 2 day look ahead, and load that into the HoloLens device. And it actually works quite well for that use case. Smaller subset of data, smaller geometry, you can actually load that into the HoloLens and you can have this type of experience. So this was driven from customers and us sort of experimenting. And as you can see here, this is quite interesting. You can get pretty tight model alignment now with an animated model and the physical job site. So what are the kind of constraints you're going to find? The next question is going to have, if you want to load a massive model, a large 4D construction simulation, not just a 1 or 2 day look ahead into the future. What do you have to deal with? And the limitations you're going to hit, you're going to find that there's hardware limitations right off the bat with how much you can load onto the HoloLens. The FBX file format, which is a common data exchange, we found also has limitations, which I'll talk about. Unity Game Engine is our tool of choice, obviously, for getting to the HoloLens. But we found that that had limitations if we wanted to get huge models to HoloLens. So we actually had to move away from Unity and develop something totally new. We also looked at mesh decimation technology as an alternative. And then the core for our technology here is called the holographic remoting framework. So just quick, who's worked with holographic remoting framework? Okay, just a few. So this should hopefully be good news, new information for you. So number one, HoloLens itself. It's a mobile GPU. It can only handle so much content. It can only process so much at a time. So if you're going to deal with a large, heavy, high-poly CAD model or mechanical model, you're going to have to look at an alternative solution and not load that content to device. You're going to have to start thinking about how do you stream graphics from an engine to the HoloLens. And because you're going to hit that limit pretty fast, and you can basically query that and see that limit through the device manager. Next thing you can try is FBX, and we tried using tools like Umbra and Simplygon to basically take snapshots from our model at different critical moments in the timeline, beginning, middle, end, or any milestone date the customer wanted, and we would push that up to the cloud, decimate the models, bring them back down, and then create this app experience for the customer. The problem with that is it was just not a scalable solution for our customer base. We couldn't expect customers to just keep exporting FBX after FBX. And then the real limitation actually was that Umbra, which is a great tool, by the way, had no support for animation. We couldn't get it to work where we could just jump through any moment in the timeline and render those frames out to the HoloLens. So then we said, all right, well, we develop a lot with Unity. We debug in Unity. And we were experimenting with streaming from Unity to the holographic remoting app. So this is an app that's free. You can download to the HoloLens. And it basically allows Unity to make a connection to it through Wi-Fi and start streaming the scene from Unity directly to the HoloLens. We thought that, well, that's great, but we can't really package up the Unity game engine and make that a product in the cloud or otherwise. So we said, well, what about if we used our own graphics engine, which is called Hoops, which is built by TechSoft 3D, and try the same thing? What's really nice about working with Microsoft is they sponsor what are called Hackfests. So the first Hackfest we got together with Microsoft, TechSoft 3D, a bunch of hardware and developers, and we said, let's try it. Let's try and take our native graphics engine, Hoops, and build something similar to what Unity has, basically stereoscopic streaming from that game engine right to that app framework. And we got that working. One point about that, though, when you're going down the route of streaming, you're constrained now by the Wi-Fi connection you've got and also the GPU you're running locally. So for this to really work and be effective, you've got to have a good high-powered laptop to run those graphics, and you want to have a Wi-Fi connection that's solid. We like to just set up a local router and have full control over that, because now we're talking about streaming frames, not loading to device. The other thing you'll find out with the holographic remoting app, at the moment, it's a one-way shot. It's just this app that you launch in the HoloLens, and then you can make a connection to it. We're now looking at how can we take that framework and build a bespoke app, a branded app, that can make a connection back to a synchro endpoint. Technically, this is all possible according to Microsoft, based on the last Hackfest that we had. So where did we get after all this? This is basically in the last 1 year of development. So we've built a direct streaming capacity within our desktop app that will go right to the HoloLens. We did instrument keyboard controls because you want to be able to manipulate that hologram in front of you in the HoloLens. So the keyboard will work, and we also build basic gesture inputs so that the HoloLens can pick up gesture control send that back to our graphics engine, update the model, and then send new frames to the HoloLens. These are the parts you're going to want. A 3D engine to work with outside of Unity. I would suggest you could talk to Unity, to TechSoft 3D. They've actually built this into their core engine now. And for us, this is the core of our 3D engine. But you could basically use that technology to build your own app if you need to. SolidWorks, by the way, is another one of their big clients. Check out the remote holographic framework. This is up on the website for Microsoft HoloLens. All the documentation is there. It's actually very easy to make a connection with Unity or with Hoops into this holographic remoting framework. And then TechSoft 3D, I would say connect with this company. They've been very good partners with us. They've been open to innovating with Microsoft, attending Hackfest, testing, trying new things, and are committed to working with us on the next steps. Oh yeah, so the next step where we're going to with TechSoft 3D, so we had another hackathon recently, and what we found is there are certain limitations with single GPU. So we were looking at, in a demo that Microsoft's developed, it's a DirectX 12 multi-GPU streaming capacity. And so this is coming down the pipeline now. So TechSoft 3D, our Hoops graphics engine, is going to be building that driver in the next 6 months. So it's not available yet, but it does work. I've seen it work in a demo that Microsoft's produced. So what this is going to allow you to do with DirectX 12 integration is basically use multiple GPUs to render those graphics and then send those to the HoloLens. So this will solve the issue with like large, massive models, and for us, allow us to finally start streaming animated graphics to the HoloLens. So that's where it's coming, DirectX 12 Azure GPU, which is on the back end of the technology. So once you have a DirectX 12 driver built, you can start to leverage Azure GPU in the cloud. And then the idea of reversing the flow is also coming down, so you can free yourself from having to use the holographic remoting app directly, use that framework, build your own application on top of that, and then push that up to the Microsoft Store. That's the idea, and then that app can make a connection to whatever your app is that you built for streaming. So this is the basic framework. Hoops is our graphic engine. It lives within our desktop application. Keyboard control is our first prototype, moves the model in the stereo view, updates the HoloLens, and then connects directly to the holographic remoting application running in the HoloLens. And so this is what it actually looks like in production. So we have right-click. This is our desktop application, just connected on a local Wi-Fi. Right-click to HoloLens. It generates this view, and that view is then streaming directly to the connected HoloLens. So there I am. I'm just wearing the HoloLens. I'm running the holographic remoting app, and then all the frames are being sent from that desktop app. And now what's cool about this is we don't have to export anything. We can just interact with our desktop app, move through any moment in the timeline, and then those graphics are going to update to the HoloLens. This is actually a real project. This is Mortensen Construction. It's the Golden State Warriors Stadium under construction in San Francisco. And the breakthrough here for us is when we tried to load that model to HoloLens directly, it just was never going to make it, impossible. But now we can actually take this out. The client can visualize their entire construction sequence with the HoloLens. So instead of sending models up to a server and dealing with decimation and this whole workflow, we're building custom applications. Now it's a generic app that can run on any model running on our desktop app and just stream those graphics over. So that's sort of the innovation, I think, there is try and use the parts that you have instead of maybe reinvent the wheel. So some code snippets here. Holographic streamer, the stream helper is the first thing you have to make is basically a connection from your 3D engine to the HoloLens to stream graphics. And then pose information, this is the other interesting thing. you need to write code that's going to be able to take the camera position, the input from the HoloLens, which is moving around quite dynamically, send that signal back to your graphics engine and get new camera positions. So you're basically taking over the camera in your native CAD application, re-rendering the frames and sending those back to the HoloLens. So this is quite different. If you think about a normal CAD app, you're just using the mouse and panning and zooming. The HoloLens sort of takes that over just by simply moving your head and updating those cameras. Now, gesture control is quite interesting. The next step is it's not effective to just use a keyboard to control that HoloLens. A real challenge is how can you be running a streaming app and pick up a gesture, send that signal back to your CAD engine, update the model, and then push it back. So it's like you're sort of manipulating the model, but through a stream, which is quite interesting. And the way you can do that is basically send raycast from the HoloLens, hit a target in your CAD model, that triggers an event in the CAD engine, and then you just update the graphics back to HoloLens. So it's a little bit of magic, I guess, there. You're not actually interacting with the model on the device, you're interacting with streaming graphics. This is kind of what it looks like. I'll have to say our first controller is like very rudimentary. It's our first prototype we got working, so it's just very simple 3D manipulator living in our 3D model, but able to interact with, scale, rotate, and move the hologram through a streaming experience. So that's where we got with that first control, and we want to improve on that. So next steps where we're going to go, we want to build that app where it'll connect to an endpoint, not the holographic remoting app, and then update our gesture control system using all these themes that are coming out with the fluent design principles of lighting, materiality, three-dimensionality, like this. And then once we get the DX12 piece built in, we're going to start running Synchro on Azure GPU, basically a headless version of Synchro that the HoloLens will just make a connection to, and then through our manipulation, we can just move through the timeline, manipulate the model, and we take the entire desktop app essentially out of the picture and just let people interact with that massive data set over the capacity built into Azure GPU through DirectX 12. So that's our roadmap, and that's sort of where we've gotten to just in the last year. And as far as my key takeaways, what I would say is when you are approaching this problem, there's two things. You can definitely load geometry to the HoloLens. So don't think that you have to go to streaming. I would start thinking if the use case is that you need to get a small data set to the HoloLens, you can still cache that, make an experience for that. But if you're dealing with massive models, animated models, large poly count models, you really have to think about direct streaming to the HoloLens. I think that's the only way to deal with that. So those are the main parts. I would say find a graphics engine. For us, Hoops did the job. Use that remoting application framework. Get your hands on massive data sets to start testing it. For us, we're very lucky. Our clients are producing these on like a regular basis. So we work with the clients, get their huge data sets in, and just start testing the envelope. And as far as what's coming next, I would say be aware if you're going to start building in this, start to anticipate a DirectX 12 driver and start experimenting with Azure GPU. And for gesture and UI controls, start to get familiar with the fluent design principles as you build UI into your framework. So that's what I've got for today. I hope that was interesting. And if you guys have any questions, we have our HoloLens and apps, and we will be available at the conference and can answer any questions. Yeah. Oh.
I'm curious, did you happen to ever have any success streaming not over Wi-Fi, but over a wired IP over USB?
HoloLens is always Wi-Fi.
Well, I mean, to reduce latency, is there any success in getting it wired and doing it over an IP over USB? Has Microsoft ever
Yeah.
support that?
So the question was, have we ever tried doing a wired connection to the HoloLens? No, we always just worked with Wi-Fi. Mm-hmm. Yes.
One of the demo videos showed the client seeing the construction management on the field, right?
Yes.
I just wonder how you manage to
Okay. So that question was, how do we get model alignment in the field of the digital model, and did we use streaming? So for that use case, we don't actually need to use streaming, because that, if you think about just a 1 week or 2 week look ahead of geometry, it actually loads into the device. For that example, we used Vuforia image targets, and then just did a model alignment, 2-point, basically an origin point and rotation, and then the model loads up. Yes.
So this architecture, it sounds like you're just streaming the events for manipulation. Are you experimenting with other manipulation controls like repeat motion or anything else in order to stream?
What's
So you're
Yeah. No, we've only been working with what the HoloLens picks up. Yeah. Oh yeah, one more question here. I'm sorry? The question was, what about multi-user experience? And that's a really good one. I should have put that in the slide. For our app where we load to device, we now have multi-user working. And streaming, that would be a really good feature to add. I totally agree with that. So we know how to work with UNet and Proton for streaming with our current existing app, which is on which loads to device. So I think that's a really good point, multi-user. That's it. Good? Okay, well, thank you very much for your time, and I hope that was useful. Thank you.